Hey guys, video on arithmetic and geometric sequences. So the key thing to know is with an arithmetic sequence, it's got that word arithmetic in it, arithmetic, and it just means you are in a sequence of numbers, you're adding or subtracting the same number to each number. So an arithmetic sequence might be 2, 4, 6, 8, 10, 12, adding 2 to every term. It might be 13, 10, 7, 4, 1, -2, -5, where we're just subtracting 3 from every term. That's an arithmetic sequence. And by contrast, a geometric sequence is one where each term is being multiplied or divided by the same number, the same constant every time. So maybe you've got 2, 4, 8, 16, 32, 64, 128. So we're multiplying by 2 every time. Or maybe we've got 10,000, 1,000, 110, 1, 0.1, 0.01, where we're just multiplying by 0.1 every time, or dividing by 10 every term, same thing. So the arithmetic and geometric sequence. And so I'll show you a few questions from the SAT and ACT that use these concepts, and so it'll make even more sense for you. So we got 24 here on the screen here, and it is it's like an arithmetic sequence of sorts. It's actually not the best one to start with, but we'll start with it anyway. And so let's just say we're actually going to use the numbers start with C approach, which is when the answers are all numbers, you can put in the middle number and just see if it works or not. So let's just try C. We'll try 16 here. So if the fifth integer was 16, and there are 5 consecutive even integers, that means you would have 14, 12, 10, and 8 as the previous 4 integers. And let's see. The sum of the first and third, 8 and 12, which is 20, is 20 less than 3 times the fourth integer. So third integer times 3, it's going to be 42. So sum of the first and third, 20, is 20 less than 3 times the fourth integer, 14. So we're just off. We're not 20 less than 3 times the fourth integer. We are 22 less. So we're close. I'll bet you it's B. I'll bet it's 14. Let's just try it out and we'll see. So there's 14, then our 5 integers would be 14, 12, 10, 8, and 6. So the sum of the first and third would be 16, which they say is 20 less than 3 times the fourth integer, which would be 36. Yep, that's perfect. So our answer is B, 14. It's actually not a good arithmetic and geometric sequences question. However, I like it because do you see how I got to the answer just by writing out all my work? It's actually a concept I use in other videos. And also numbers start with C, putting those two approaches together. Start with the middle answer when they're all numbers. Try it out, write out your work in a really neat way, and then it's very easy to kind of see and think your way to the answer. But now let me get you to a better arithmetic and geometric sequences question. There we go. We'll do question 7 there in a second, and we'll do question 6 here. This is from the ACT. Basic concept is what matters. Arithmetic sequences means you're adding or subtracting the same number to every term in the sequence. Geometric sequence means you're multiplying or dividing by the same number every time across the sequence. And writing out your work, like we had to do in the previous question, actually is very key. Just write out the sequence of numbers and you can start to see and think really clearly. So if we look at question 6 here from an ACT, it says the second term of an arithmetic sequence is -11. That's the second term. So we'll put in a little space for the first term. Third term, -38. So they want to know what the first term is. Well, if it's an arithmetic sequence, it means we're adding or subtracting the same amount every time. Looks like we are subtracting 27. So to get from -11 to -38, we would have to subtract 27. So we must have subtracted 27 from the first term to get to -11. So that is going to end up being, I believe, +16. Yeah, which is J. So knowing that in an arithmetic sequence, we are adding or subtracting the same amount every time, we write out the list of numbers, the sequence, and then it's pretty easy to get to our answer. Let's try a geometric sequences question here. Question 7 here. The first term in a geometric sequence is 1, 1, negative 3, 9. So it looks like they're multiplying by negative 3 every time. And so that is the 1, 2, 3, 4th term. So the 5th, 6th. They want to know about the 7th term. We'll just keep multiplying by negative 3. So for the 5th term here, we would have gotten positive 81. Then we got a negative 243 for the 6th term. 7th term is going to be positive 729. Answer choice E. And we know that because it's a geometric sequence and it looks like they're multiplying every number by negative 3, as a geometric sequence would do. So that's it. Write out your work, write it out really clearly and neatly, and you'll be able to get these questions quite easily. And just know, arithmetic sequence, adding or subtracting the same number to every term in the sequence, geometric sequence, multiplying or dividing the same every term in the sequence by the same number.